an advanced monitoring system of Syringe pump based on Internet of Things. Technological advances can encourage new innovations by applying the concept of Internet of Things, a concept that aims to broaden the benefits of continuous internet connectivity such as data sharing, remote control, and including objects in the real world. For example, home electronics, any equipment including living things, are connected to local and global networks through embedded sensors and are always active. Several studies related to applications include, in the agricultural sector, smart home, smart fish farm, health sector, and many more. The Internet of Things concept is also widely applied to medical equipment, such as research conducted by a researcher from the Department of Electromedical Engineering, Poltech's Ministry of Health, Surabaya, Agatha Putri Jr. and colleagues. Their research offers out applications for vital signs monitoring patients who need treatment intensively, and the vital condition can be monitored remotely. Internet of Things is also applied to the patient monitoring system, heart disease monitoring, remote health monitoring system, and many medical devices. A syringe pump is a medical device that is used to provide liquid medicine or nutrition into the patient's body in a certain amount and time regularly and automatically. Syringe pumps are designed to push liquids, generally driven by a stepper motor or a direct current motor, which is controlled by a microcontroller. Syringe pumps are applied in various fields such as the healthcare and pharmaceutical industries. But unfortunately, the current syringe pump still has several weaknesses, including the absence of notification if the liquid inside is about to run out or experience blockage. These problems will only be known if observed directly at the location. The conventional supervision using of syringe pump in most hospitals is not currently based on Internet of Things. When the medicine is going to empty or facing occlusion and did not recognized by the nurses, it can be fatal, even if it was already equipped with alarm. For example case, when the nurses and other medical team are having a rest and then the medicinal liquid which induced into patient is running low and the alarm goes off. What will happen? They are not hearing and the patient condition will be worse. The solutions offered in our research are: an app-based syringe pump has been designed, which can provide information at any time to medical employees and doctors. So the research is expected significantly support syringe pump work by the medical team at any time. Here, safety is everything. We offer a syringe pump design that is equipped with a Nodon Q8266 Wi-Fi module to provide notifications via a smartphone, so that nurses or doctors can know the alarm even though they are outside the patient monitoring room. So this is expected can improve patient safety. The syringe pump is equipped with a near-empty alarm to provide information that the drug or nutrient liquid will be running out soon. Alarms have a vital role in providing information to nurses or doctors. The experiment was conducted by using a 50 ml syringe with a drug flow rate of 100 ml. At the same time, the target volumes are 5 ml and 10 ml. The experiment used the original mechanical system of the syringe pump Bron-type compact. This mechanical system has functions to control the rate of the drug in the syringe and an optocoupler sensor to monitor the number of rotations of the stepper motor. Other components used include the Atmega 16 microcontroller module, a motor driver to control the stepper motor, a TOC16 display to display the drug rate and the amount of drug that has entered the patient, as well as the NodeMQ ISP8266 Wi-Fi module to model alarms in the form of notifications sent via smartphone. In this study, the volume counter sensor was tested with a thermal measuring cup with tolerance of 0.1 mol. This measurement aims to find out the speed of the drug flow rate driven by a stepper motor. This test also aims to determine the amount of drug that still remains in the syringe before the alarm and nearly empty notification is sent to the smartphone. When the device is turned on, the microcontroller waits for a command from the push button that is setting the drug flow rate. The push button also gives an order to the microcontroller to start the drug delivery process. The stepper motor will drive the syringe at a speed according to the setting and controlled by the motor driver. The drug flow rate is censored by the volume counter sensor. The volume of drug that has been delivered in real time will be displayed on the screen. Nearly empty sensors will detect drugs that are running low so that an alarm sounds and a notification will be sent via smartphone to the user. Nearly empty alarms and notifications occur when the medication amount is 10 ml left at the same time. Notifications are also sent via smartphone. Alarms and notifications always pop up every 30 seconds on smartphone until there is an action from the user to reset the alarm, stop the drug or continue it. The calculation of the average hour at the target volume of 5 ml 0.6, while at the larger target of 10 ml 0.1. Errors can't be caused by the accuracy of the measuring cup, which is read manually by the researcher. Based on Emergency Care Research Institute (ICRI), the requirement regarding the maximum permissible error in the syringe is 5, so that the syringe pump equipped with a night system is feasible to use. A nearly empty notification is sent via smartphone when there is only 10 ml of medication remaining in a 50 ml syringe, different from using another syringe size. This is due to the use of an optocoupler sensor that is oriented to distance, not the diameter of the syringe. Compared to previous research conducted by MyHarger, they use a web-based application using the programming language with the missile database. This study is more focused on dose calculation using a web application. After getting the data on the drug rate code, then it is entered manually into the syringe pump. In our study, was more focused on patient safety. When the drug in the syringe pump is nearing empty, it will get a notification in the form of an alarm to the smartphone via Internet of Things. This is due to the limited hearing distance of the alarm sound. The drug rate data setting curve is not changed, following the syringe pump standard. The only limitation or weakness in this research is the limited use of a syringe pump on the device. This smart syringe pump can only detect syringe pump sizes of 30 and 60 ml. In the future, the limitation will be overcome by testing all types of syringe pump sizes. This conclusion, a smart syringe pump offers a good performance in delivering early warning of notification when the device is running low of medicinal liquid and facing occlusion. Patent potential commercialization. Our publication, application about using NodeMQ ISP8266 on the syringe pump device to increase patient safety. Journal, Indonesian Journal of Electronics, Electromedical Engineering, and Medical Informatics. In addition, our product innovation has already registered intellectual property rights No. X00200,126,823. Our product will also be refined for later mass production by companies under the auspices of our campus spin-off company, Pigmentary Major.